In this lecture, we're going to see that if we try and pass objects in an array, these objects are going to be copied. And we are seeing that exactly here because now we can prove this with copy constructors. So here is a simple example. We have a few person objects, S1 all the way to S3, and we are using these person objects to put data in an array which is called students. It is an array of person objects, and we're going to put our person objects inside, and we're going to see what happens. So what is going to happen, what we have inside the array are going to be copies of the objects that we put in here. And we're going to see copy constructors called as this array is being set up in our C++ program. This is what I want you to see here. Putting objects in an array is going to create copies, and you need to be aware of that. Another place where we're going to be making copies is if we use a range-based for loop like we do here. So we are basically having this array and we are looping around it, trying to set the first name to whatever we want. So what this is going to do at each iteration, it's going to create a copy of the person object it is at from this array here. So this copy is going to be scoped to our for loop, the body of the for loop, and when the iteration is done, the local copy is going to be destroyed. When we hit the next iteration, a new copy for the new element is going to be created, and we're going to keep going until we hit the end of the range-based for loop. So this is something you need to be aware of. If you want to avoid copies, you can use references in your range-based for loop, and this is not going to create a copy, and you're going to see that the copy constructor is not being called as your loop executes. But you should know that regular loops don't make any copies, so if you set up something like this, you're going to be using the actual elements that are stored in the array. You won't be making copies in the for loop here. Okay, now that you know this, let's head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is Objects in Arrays Are Copies. What a good title. We're going to grab the template files here and we're going to paste them in place. And we're going to grab the person class from the last lecture because we don't want to redo this. We already have done this, so we can reuse this. We're going to put that in our current project, and then we're going to open this in Visual Studio Code. Let's do that. This is going to open our folder with our files, and we see the main CPP file here. We can clean this up a little bit. And we have our person class, which has some things we don't really need. So we just need the copy constructor here. So let's put this in. So we're going to delete all the other things we don't need here to keep this class clean and nice. And we're going to head over to the person CPP file, and we're going to remove all the dirty things that are not used here. Everything that is commented out, we're going to remove. Let's do that. And we're going to keep the copy constructor that is delegating to the other constructor here. This is going to work. Okay. So now what we want to do is to set up an array of person objects. But for that to work in main, we need to include the person class in our main file here. So let's do person.h. And we are going to create a few person objects. We're going to say person1, p1, and we're going to pass in John, and we're going to say snow, and we're going to say age is 25, why not? We're going to do person2, and we're going to say, let's say Johnny Drill is 5 here. We can do this. So we can go down here and create an array of person objects. So let's do that. We're going to say person, and we're going to say students, and we're going to make this an array, and we're going to initialize this with data that we have in the objects here. So we're going to just put in P1, P2, and P3. Let's see what happens if we build and run this code. Let's put a little separator here to be able to separate what we get from the constructors here from what we get from the array setup here. We can build our program. We're going to use GCC. You're going to see that the build is good. We're going to bring up a terminal, and we are going to go up and clear. Let's clear and run Rooster. You're going to see that it's saying copy constructor called, copy constructor called, copy constructor called. So what this is going to do after we set up our person objects, it's going to copy each of these guys and keep a local copy in the array here. This is what is happening, and I wanted you to see this with your own eyes. We can even make the message in our copy constructor more descriptive. So we can say copy constructor for the name and say the last name, for example. So we can say called for, and we can say the last name here. I think we can say that last name. We have access to this and the person object we just constructed. So we can print this out. Let's put a space here so that we can really see this. So we're going to build with GCC again for these changes to be taken into account. And we're going to clear and run Rooster. You see that the copy constructor is going to be called for John because John is the first element we copy into the array P1 here. The copy constructor is going to be called for Sam because that's the second person object. And we have Johnny, who is going to be copied in the first position here. And what we have inside our array are going to be copies from the outside here. I think we can really prove this, that they are going to be living at different memory locations. So we can go on top here and say P1 printful, we can print the information, and we're going to say P2 printful and P3 printful. And we can loop through this array and print at each iteration and print the information and really prove that what we have is a copy. So let's do that. We're going to use a regular loop. We're going to say for size t I, and we're going to initialize this to 0. We're going to keep looping as long as I is less than std size, and we're going to increment here in our incrementation part, and inside what we want to do is just print the information from the current element in the array. So we're going to say students, we're going to access the elements in the array, we're going to say student, and we're going to say printful, and we're going to print information from the inside. So let's do that. We're going to build with GCC, and the build is good. We can clear and run Rooster. Let's run Rooster. And you're going to see that before we set up the array, this is going to be the information. So the person object is going to live at this address P1. So that's P1 here. P2 is going to live at this address. P3 is going to live at this address because we are printing this information here. But once we hit the body of the loop, we're going to see that John Snow is living at this address here, and he was living at this address from the outside of the array. So you see that what we have inside the array are going to be copies. It's not going to be the original stuff, and you need to be aware of these copies. Okay, the second place where we're going to have unintended copies is if we use a range-based for loop. Okay, so what we're going to do to really prove that, we're going to put another separator, and we're going to put a few dashes in here. How many did we use there? Let's say it's 4. I think this is 4. So we're going to use the same thing here. And we're going to set up a range-based for loop, which is going to loop through this array here, printing the information. It's going to do the same thing we do here, but it's not going to be using a regular loop like we did on top here. I just want you to see that that's going to create copies, and you need to be aware of them. So let's do that. We're going to say for person P in our array of students, and we're going to grab this P person and print the information. This is how easy a range-based for loop can really be, and it is really cool. But we're going to see that after these dashes, we're going to be calling the copy constructors. Let's build and really prove this. So we're going to build with GCC. Okay, the build is good. We can clear and run Rooster. We're going to see that we're going to call the copy constructor for John and Sam and Johnny when we set up the array. That's what we see when we set up this array here. And after we print each of the elements in the array, we're going to print the second dashes, which is here. And we see that we have a couple of copy constructor calls. We're going to see the copy constructor called for John, and we're going to print the information about John. We're going to see the copy constructor called for Sam. We're going to print the information about Sam. We're going to see the copy constructor called for Johnny, and we're going to print information for Johnny. What this is really doing, at each iteration, we're going to set up a copy of the current element we are at in this array here, and this is what we see. And you need to be aware of these copies again. You need to know this because sometimes you don't want copies, and you need to do something more to avoid those copies. In this case, in our range-based for loop, it is really easy. We can pass the current iteration element by reference. So for example, we can say person reference P here, and this is going to be a reference. It's no longer going to be a copy. If we build it now, we're going to see that the copy constructors are no longer being called because what we have inside the loop is going to be a reference to the original data that we have in the array here. Okay, so this is what we have. Let's try and build and really prove that this is not going to create copies. You see the build is good. With our reference, we're going to clear and run Rooster. Now you see that after the second pair of dashes, we're not using the copy constructors anymore because what we have are real references to the data we have in the array. And if you look here, you see that the address in memory are the same. Okay, so this is really cool. If we go back and look at what we printed earlier before this run here, you'll see that the data we have in our, and it should be gone. It's gone. We don't have this, but we can take out the reference here and build again and show you that the data we have in the array is going to be different from the data we have in the loop here, because what we have in the loop is a copy. So they are going to be living at different memory addresses. Let's run and really prove this to you. You need to see this. So the build is good. We can clear and run Rooster. So look at what we have in our range-based for loop. The person object is going to be living at this address. This is Jon Snow. He's going to be living at an address that ends in A70. But in the array, Jon Snow is living at an address that ends in AC0. So these two things are different copies we have, and we are making a copy in the range-based for loop here. Or to be exact, we are copying whatever we have in the array when we loop through this range-based for loop here. But we can avoid these copies again using references. We can do this. And if we run the task to build with GCC, we're going to see that we're not going to call the copy constructors, but we are also not going to be making copies, which is really cool. So we're going to run Rooster, and we see that now the person we have in the range-based for loop is the same person we have in the array because the addresses are the same. You can see this right here. And this is really cool. So one thing you should really be careful about is these copies. You can avoid them with range-based for loops using references. And you have to know that with regular loops like we did on top here, we're not going to be making any copies. We're basically going to be referencing exactly the same thing we have in the array. Okay, so this is something you need to keep in mind. And this is really all I wanted to share with you in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about shallow copies and deep copies, and we're going to really see the difference between these two things. So go ahead and finish up here and meet me there.